What's up, everybody? I'm Kyle,
I'm Skylar.
and today you're listening to Audibly Astronomy, the podcast where we talk about interesting topics in astronomy.
This isn't how we plan to be doing this podcast for you guys, but because of COVID-19, we have to do this on Zoom, so hopefully you can hear us okay.
So one of the most fascinating topics in astronomy is extraterrestrial life. Humans have always looked up to the sky and asked, can we be the only ones?
Today, we will try to answer that age-old debate, kind of. Statistically, we should have come in contact with other life forms by now. The Fermi Paradox tries to explain why we haven't. And all a paradox is a list of things that we assume to be true. And in that list of things, one of them must be false.
So here's our list of things assumed to be true in regard to the Fermi Paradox. A, our civilization is not the only technological civilization in the galaxy. B, our civilization is not the first to have appeared in the galaxy. It's not the most technologically advanced, and it's not the only one seeking to explore the cosmos and communicate with other civilizations. C, some extraterrestrial civilizations have mastered interstellar travel and undertaken a galactic colonization program either with or without self-replicating robots. D, galactic colonization is a relatively fast undertaking and could be achieved in a relatively small fraction of the galaxy's age, which could be less than a few 100 million years.
So to further elaborate on that idea, we think it's important to understand how old space actually is. So the universe is 13.8 billion years old. The Milky Way is 13.6 billion years old. The Sun and Earth are 4.5 billion years old. However, some of the oldest stars in our galaxy are almost as old as the Milky Way, 12.8 to 13.5 billion years.
So technically there could be billions of older Earth-like planets in our galaxy that have life.
Exactly. So before we get any further into the nitty-gritty, let's focus on some background. How did this paradox even come about?
Well, Skylar, I can kind of help you out with that question. According to Duncan Forgan, author of the journal article Solving the Fermi Paradox, the Fermi Paradox wasn't actually proposed by Enrico Fermi. All he did was have a conversation with his nuclear physicist bros who were talking about the possibility of light-speed space travel. And he said, "Where is everybody?" So the paradox is actually proposed by a guy named Michael Hart, and he published an article creating what we know as the Fermi Paradox today.
So a question you may have is, how do we know statistically there should be extraterrestrial life out there? Well, in 1961, Frank Drake wrote down a long equation that multiplies deciding factors as to how many civilizations there should be in the Milky Way. You can plug in essentially really optimistic or really pessimistic numbers to come up with your own conclusion. You can be really optimistic, being if there are 50 to 100 billion habitable planets, then all of them have civilizations, or you can be really pessimistic, assuming that we're the only ones to exist. When me and Kyle plugged in our own numbers, we concluded that there's about 700,000 civilizations in the Milky Way, not bad, but only 0.0028 civilizations in our own local neighborhood. So let's talk a little bit about theories about how people are trying to solve the Fermi's paradox.
So one of the theories is in an article by Nikos Prantztos, which I always mess up that name, but it's titled A Joint Analysis of the Drake Equation and the Fermi Paradox. He simplifies the Drake equation and basically concludes that we're much less likely to determine signs of other civilizations via radio transmissions. For us to detect civilizations with radio signals, they would have to be broadcasting for at least 10,000 years, or even millions, depending on the number of civilizations present at the time, which we've only been broadcasting for about 100 years. It's also possible that we live in an unoccupied region of space, so these radio transmissions could take longer to reach us, or never even reach us at all.
That's true. Another theory is based on an article titled Fermi's Paradox, Extraterrestrial Life and the Future of Humanity. It's a Bayesian analysis written by Wilhelm Verdel and Ole Hagstrom. They discuss the probability that life will evolve into a super civilization. It talks about how the number of potentially life supporting planets in the observable universe is large. But that means that the probability that those planets develop intelligent life and the chance that the life form goes on to develop technological super civilization visible all over the observable universe is very small.
Yeah, just because we find habitable planets doesn't mean that it's always good news. Habitable planets without evidence for life could be explained by a great filter, meaning life is harder to survive than we think. There are filters that life has to meet in order to survive. Humanity has passed all those filters this far, but will we pass the ones still ahead of us? I mean, we're in one right now, COVID-19. I mean, it's a crazy time to be alive and could potentially make us go extinct or endanger us, or I mean, it could hurt the population a crazy amount. So, I mean, that's what the Fermi paradox is going over, is like there's really no answer as to why we haven't seen these civilizations when we should have. And I mean, the only real way to find out is to go out in space and explore and determine for ourselves personally, or with those crazy robots that replicate each other and do that sort of thing, for ourselves.
Exactly. All right, that is all the time that we have today. I hope that you all learned something new about the Fermi paradox.
Peace out, friends.
Stay safe.